Hey guys, Joe back at it once again with some OCR FSMQ past papers, and today we are doing the June 2011 examination. So if you haven't seen the first four papers that we've done, 2007 to 10, and then they are on a playlist on the channel, as well as all the lessons that I delivered for my class. But yeah, without further ado, let's get into things. I'll just get my pen ready because I forgot to do that, but here we go. So, question 1. Determine whether the point 5, 2 lies inside or outside the circle whose equation is x squared plus y squared equals 30, but you must show you're working. So, the way you test whether a point is on a line or a curve is you let the x equal 5 and the y equal 2 if you're given this coordinate here, because that's what it's telling you, that when x equals 5, y equals 2. So there you go. So 5 squared add 2 squared equals 29. And 29 is less than 30, therefore it must be inside the circle. Because if we draw a circle, where it's around O, the radius in this case would be root 30, which is probably about 5.5, and the point 5, 2 is 5 along and 2 up, so immediately that's a 5 there, so that's a little bit less than the radius, and you're only going 2 up, so that's a little bit off, but at the end of the day it is inside the circle. Question 2, by the way, that was 3 marks, so not too bad for just putting a couple of numbers into an equation. Question 2. The equation of the curve is y equals x cubed minus x squared minus 2x minus 3. Find the equation of the tangent to this curve at the point 3, 9. So, first thing we need to do is find the gradient. So we do y dx, power to the front, knock 1 off the power, 3x squared minus 2x minus 2. And we'll put x coordinate in, so when x equals 3, dy dx equals 19, therefore the gradient of our tangent is 19. Then we use the line equation, y minus b equals mx minus a. We'll put in with numbers, and then we expand, and then because I like my x's to be positive, and I like my equations to generally be in the form y equals mx plus c, I take the 9 over the other side, and I call it y equals 19x minus 48. So that's 5 marks, not too bad. Question 3 then. In the triangle PQR, PQ equals 8, RQ equals 9, RP equals 7. Part 1. Find the sides of the largest angle. So here we go. Draw yourself a triangle, like that. Call the sides 7, 8, 9. The largest angle is going to be the point where the two smaller sides join up to the biggest side, so it's going to be this angle here. So we're going to use the cosine rule, and the cos of A equals b squared plus c squared minus a squared over 2bc. Put in your numbers. Your b and c will be these ones because they're the ones attached to the angle, and your a is going to be the number 9 there because it's opposite the angle. So we'll put in the numbers, put in with calculator, do the shift cos, and you end up with 73.4 degrees. 4 marks, not a bad question for that. Calculate the area of the triangle then. So we have to go back to some of the content we learned on trigonometry, and we know that an area of any triangle is a half AB sine C. So it's half times the two sides attached to the angle times the sin of that angle. So there we go. It's a half times 8 times 7 times sin, 73.4. So the area of the triangle is 26.8 centimeters squared. Question 4 then. Solve the equation 5 sin 2x equals 2 cos 2x in the interval 0 to 360. Give your answers correct to 1 decimal place. So we can't have two pieces of trig in one equation. That's unsolvable. So let's divide by cos 2x and 5 because I think I know where this is going. Sin 2x over cos 2x equals 2/5. But a sin over cos is a tan, so we'll call it tan 2x equals 2/5. We do the shift tan of that. Well, hold on a second. It says for 2x, but we want it for x, as it says there. So at the end we're going to have to divide our answers by 2. But first we're going to have to increase our range to 720, because that's only for x. So if we times everything by 2 there, we still get 0. We're going to get 2x in the middle, and we're going to get 720 there. So that's where that comes from. And then half our answers for x. So we do the shift tan of that. So 2x equals tan to the minus 1 of 2/5. So 2x equals 21.8. But remember, tan solutions come every 180 degrees, because if you remember the tan graph, it goes like this. So it goes up like that, and then comes down, and then goes like that. So they keep coming around like that, and the distance there is 180 degrees. So 2x equals 21.8, 201.8, 381.8, 561.8. Then we divide all those answers by 2, and we'll get 10.9, 100.9, 190.9, 280.9. So 5 marks there, 5 well-earned marks. That is Core 2 mathematics there at A level. So don't worry if you don't fully understand that. You're not meant to at your age. Well, I assume your age. Number 5 then. The coordinates of the points A, B and C are 2, 1, 5, 2 and 4, 9 respectively. Part A. Find the coordinates of the midpoint M of the line AC. So AC will be these coordinates here. Midpoint of that is just the average of the x's, average of the y's, so we get the midpoint to be 1, 5. Show that BM is perpendicular to AC. So we're going to have to find B to M. So the gradient of that is back take back over front take front. 2 minus 5 over 5 minus 1, which equals minus 3 over 4. And the gradient AC, back take back over front take front, so 9 minus 1 over 4 minus minus 2, which is 4 over 3. The gradients are negative reciprocals of each other, therefore they are perpendicular. 3 marks there. Part C then. Use the result of Part B to state the mathematical name of the triangle ABC. Now this is very, very naughty of the examiner to do, because they're assuming you're just going to think that, because we've got that there. So there you go. Right angle triangle. Surely that's the correct answer, because perpendicular. Oh, pardon. That was a bad drawing there. So I'll erase that. Perpendicular angles are obviously at 90 degrees to each other. So I instantly thought right angle triangle. Turns out it's actually a right angled isosceles triangle. Now I'm not sure how you're meant to interpret that from the fact that it is that the lines are perpendicular. But hey ho, that's not great, is it? I guess actually thinking about it, if we get our diagram, it is at the point M, and then the line is going up like that, and then obviously joining A and C, they will actually be equal. So right angled isosceles, I see where they're coming from, but it's very easy to overlook. Prove this by another method though. Well, the line AB is root 50 once you do back take back squared added to front take front squared, and BC is also root 50. Therefore, 2 sides are equal. Therefore, it's an isosceles. Just having a drink there. Question 6. Solve the inequality x squared minus 12x plus 35 is less than or equal to 0. So solve your quadratic. So say that, and then draw your graph. So obviously x equals 7 and x equals minus 5. So it cuts through there and goes below the graph, and it wants to be less than or equal. So you look at the region that is under the graph and you say, well, it's between 5 and 7. Then write that as an inequality and say that 5 less than or equal to x, which is less than or equal to 7. So that's question 6. Question 7. Determine whether or not each of the following is a factor of the expression that you must show you're working. So x minus 2, you just shove a 2 through, and it equals 0, therefore it's a factor. F minus 1, when you put minus 1 through, you get 12, therefore it's not a factor. So that's part 1 done. B, factorise the function that. So what we're going to do is take our factor, then divide it in. So we do that. So x minus 2 divided into x squared plus 2x minus 3. You ask yourself, what do I times this x by to get this x cubed? And you say x squared. You put it on top, and then you times throughout, and you get x cubed minus 2x squared, and then you subtract vertically, and you'll get x cubed minus x cubed, so they'll die, and then 0 minus 2x squared, minus 2x squared, sorry, which means that's a positive, and the other two drop down, and then you do the same again, and you end up with 0 at the bottom, which is what we worked out up here. So you've done it right, and you've got yourself a lovely quadratic at the top, and you shove them together, and then you solve it, and you call x equal 2 minus 3 or 1. And that is the question done. Question 8 then. On the axes given, indicate the region for which the following inequalities hold. You should shade the region which is not required. So through the cover-up method, if you cover up that, then you get 5x equals 30, therefore x equals 6, which I believe is this here. I just pasted it in off the mark scheme, because you should know how to draw lines. And then if you cover this up, you get 3y equals 30, therefore y equals 10, which is that there. And then 3x equals 12, therefore x equals 4. And y equals 12, so you put a cross there. Join them up, shade under. Y is always greater than 0, x is always greater than 0, because we're always in the positive quadrant. Find the minimum value of 6x plus y to these conditions. Well, 6x plus y equals c. Minimum point is at 0, 12, because if we let that equal 6, for example, x will equal 1, y will equal 6, which is somewhere there, I think. And then we'll draw the line, and we'll go in a parallel fashion. And the first time you hit is there, up here. So it'll be this point here, which is 0, 12. So there you go, 7 marks on that question. Not a bad linear programming one, that. And then you put your 0, 12 back in, and you say 12 quid. Number 9 then. The gradient function of a curve is given by dy dx equals 3x squared minus 2x plus 4. Find the equation of the curve given that it passes through the point 2, 2. So we integrate with respect to x, add 1 to the power, divide by the new power. You get that. Don't forget your c, because there's a constant there. And then we tidy up. Well, we didn't tidy up actually, but we've been given some extra information about the question. So when x equals 2, y equals 2, therefore we do that. 2 equals 3 lots of 2 cubed over 3. 2 times 2 squared over 2, plus 4 2's plus c. Therefore your c is a minus 10, and then you rewrite it for the examiner, replacing your c with a minus 10. Question 10 then. You were given that sin theta equals 2/5. Using the identity sin squared plus cos squared equals 1, find the exact value for cos theta. Well, if sin theta equals 2/5, then sin squared theta must equal 4/25, because 2/5 squared is 4/25. Cos squared theta equals 1 minus sin squared theta. Therefore, cos squared theta must equal 1 minus 4/25. Therefore, cos squared theta must equal 21/25. Therefore, cos theta must equal root 21 over root 25. So it's root 21 over 5. Exact answer, remember. So we just leave it in that form there, fractional form, like that. No shift causes. Question 11 then. Eggs are delivered to a supermarket in boxes of 6. For each egg, the probability that it is cracked is 0.05 independently of other eggs. Find the probability that in one box there are no cracked eggs. Well, x can be binomially distributed as 6, 0.05. We want the p of x equals 0. That is 6c0 times 0.05 to the 0 times 0.95 to the rest. Put that in your calculator and you get 0.735. 2 marks. Part 2. In one box there is exactly one cracked egg. P of x equals 1 then. 6c1 times 0.05 to the 1 times 0.95 to the rest. Put it in your calculator, you get 0.232. Not bad for 4 marks, that second part there. Right then, this is the hard part of the question. The manager checks the eggs as follows. He takes a box at random from the delivery. He accepts the whole delivery if the box contains no cracked eggs. He rejects the whole delivery if the box contains 2 or more cracked eggs. If the box contains 1 cracked egg, then he chooses another box at random. He accepts the delivery only if the second box has no cracked eggs. Find the probability that the delivery is rejected. P of x is greater than or equal to 2 because he'll reject it if it contains 2 or more cracked eggs. But the P of x is greater than or equal to 2 is the same as 1 minus the P of x is less than or equal to 1. Which is the same as 1 minus the P of x equals none, add the P of x equals 1, which is here and here. So we just paste in the numbers, we get that, which equals 0.0328. But we've also got a second part of this. He says if the box contains 1 cracked egg, then he chooses another box at random. So this is the P of x equals 1, and then he times that by he accepts the delivery only if the second box has no cracked eggs. So it's x equals 0, which is that. That's where I got that from. So P of x equals 1 is 0.232. Hold on a second. I'm trying to work out what I've done myself here. Now there's that part there. And then you're adding on 0.265 times 0.0328. I'm not entirely sure whether that's right. The first bit is definitely right, but I think the second bit you would do this bit. So you'd add on whatever that is. But check the mark scheme on that one. But I assume I checked it at the time and that should have been right. I'm not entirely sure what I've done there, but hey ho, we'll leave it for now. But hopefully you guys get the idea. Question 12 then. 2 cars A and B move away from rest at a point O on a straight road starting at the same time. So car A moves with a constant acceleration of 2 meters per second squared. Express the displacement of car A after time after time t seconds as a function of t. So I've just told you the answer. The relationship between acceleration and displacement is integrate twice. So it's constant acceleration. Well, it's actually constant acceleration for the first bit. So use SUVAT for part A. So u equals 0, a equals 2. We want s. So s equals ut plus a half at squared. Put in the numbers. S must equal t squared. So that is your answer for the first bit. But you would have got the same if you integrated it twice. You would have got s equals t squared. Part 2 then. Car B moves with an acceleration given by a equals that. Express the displacement of the car after t seconds as a function of t. This time you are going to have to integrate twice. So we integrate once and we get v equals t squared over 4 plus t. You would get a plus c as well, but because it starts from rest, we can say when t equals 0, v equals 0, therefore c equals 0, therefore we just call it that. Integrate again and you get that. You would get a plus c again, But because it starts at a point at the origin, it means it hasn't moved. So when t equals 0, s equals 0, therefore c equals 0. So that's that. Part C then, find the time at which the cars are the same distance from O. So they're the same distance when they're equal to each other. So we set them equal to each other. Times through it by 12, and you get that. Take people over the other side, you get that. Take a t squared out, you get that, and t minus 6. So t must equal 0 or 6. We knew it equaled 0 when they're at the same point, and it also equals 6. Find the distance they've travelled in that time. So put your 6 back through one of the displacement formulas to get the distance. So s equals t squared, which equals 6 squared, which equals 36. Draw a sketch of the velocity time graph. That's just pasted from the mark scheme. That's what it would look like. One of them has constant acceleration, so it's a straight line. The other one's variable, so it'll go like that. Right then, 13. A pyramid, I'm not going to read it actually. Well, no, I will. A pyramid has a square base, ABCD, with vertex E. E is directly above the centre of the base O, as shown in figure 13. The length of the sides of the base are each 2x meters and the height is h meters. The lengths of the sloping edges AE, BE, CE and DE are 5 meters. Show that 2x squared equals 25 minus h squared. Right, so OA squared, which is O to A, where's my pen? There it is. So O to A is that line there, and this is x, and by definition, because it's a square base pyramid, that must be x as well. So we say x squared plus x squared, which equals 2x squared, so that line there is 2x squared. Obviously rooted like that. But 2x squared plus h squared equals 5 squared, because that added to that is equal to that. So 2x squared plus h squared equals 5 squared. Therefore h squared equals 25 minus 2x squared. I do realise I've slightly deviated from that, but it's the same thing. Volume, so here we go. Show that the volume of the pyramid in V meters cubed is given by V equals that over that. So volume equals a third times the base area times the height. Don't panic, you were actually given that at the bottom of the question. So you get that. Base area is obviously 4x squared, because x squared, 2x squared times 2x squared. Sorry, it's 2x times 2x, which is 4x squared, and the height of the thing is h. So we get that, which is, but 4x squared is 2 lots of this thing up here. So it's going to be 2 times 25 minus h squared. So you can paste that in and call it that. And then you tidy up and you get that, which is what the examiner wanted you to get. But as h varies, the value of h for which v has a stationary value, I'll find it. Right, stationary means diff and set equal to 0, so don't panic, just because it's not dy dx, you can still differentiate it. So we say dv dh, d left, d right, we've just gotten an equation for v, which is up here, and you do d left, d right, so dv dh, power to the front, not 1 off the power, and you get that. Then you set that equal to 0. If something's equal to, if a fraction's equal to 0, that means the top must be equal to 0. So we'll say that. Take the 6h squared over the other side, you get that. Divide both sides by 6, you get that. Therefore, h must be root 50 over 6, or 5 root 2 over root 6. Whichever you want. Right, so prove that this stationary value is a maximum. Well, what you do there is you have to differentiate it again. So d squared v over dh squared equals power to the front, not 1 off the power. You get that, which equals that. And then if you put that h value in there, it's going to be negative. Therefore, it's a maximum point, because remember, if it's negative, it's a maximum. If it's positive, it's a minimum. Part 5, calculate the angle between the edge AE and the base when h takes this value. So OA squared obviously equals 2x squared still, AE equals 5, and EO equals root 50 on 6. So sin theta equals opposite over hypotenuse, so it's going to be root 50 over 6 over 5, which is 35.3 degrees once you've put that into your calculator. So a bit of a tricky question there, a little bit over the top, but hey ho. Question 14 then. The cross-section of a speed hump is modelled by the region enclosed by the x-axis and the curve, where y equals that. Write down the maximum value of 1 minus x minus 1 to the 4. Well, 1 minus anything to the 4 will be less than 1. Therefore, the max value will be when 1 when x equals 1. Because if you think about it, if I did 1 minus x minus... sorry, let's just change that again. All in on slide. So, if we say... clicked off my pen. This has been a bit of a nightmare, this video, actually. If we said 0 minus 1 to the 4, because it's a positive power, it'll always be positive. So 0 minus 1 is minus 1, but times that to the 4, it'll be 1. So it'll be 1 minus 1, which equals 0. And if we did 1 minus 2 minus 1 to the 4, it'll get 0 again, because it'll be 1 minus 1, which is 0. So the best you're ever going to get out of it, well, that's actually shown by the graph here. So the maximum of it is going to be at this point, which is 1. So you could do that. And therefore, hence write down the maximum height of the speed hump. Well, it's going to be this point here, so it's going to be there. So that's going to be 0.2, which is there. Right, I'll get rid of this ink off the slide because it's a bit obnoxious. So there you go. So show that y equals a fifth of that. So y equals 1 minus brackets x minus 1 to the 4. Now we could use a binomial expansion, but I just called it x minus 1 squared times x minus 1 squared, which is that. Square the first, square the second, twice the inner product. And then you do that. Expand that. And you get that. So the 1s will die, because you're going to get 1 minus 1. And then you sign change everybody inside the bracket, and you get that. And that's all over 5, therefore it's a fifth of that. Find the area of the cross-section of the speed hump. Well, that's the area under the curve, which is the integration between 2 and 0. Dump the fifth outside. He's a constant. He doesn't care. Just dump him outside and call it that with respect to x. Add 1 to the power, divide by the new power. Shove your 2 in, shove your 0 in, take them off each other. But remember, the fifth is still outside waiting. So the fifth comes to join the action again at the end, and you say 8 over 25 meters squared. And that is that. That is the 2011 paper. It's a little bit harder than usual. It's yeah, a nice paper, but obviously some nasty questions. 7 marks for the last question, very last question. I don't think it's that hard if you know how to integrate between limits, but yeah, hopefully you guys have enjoyed or found it helpful. Please leave a like if you did. Leave your comments down below if you have any issues with anything I've said. And the mark schemes and papers are on the FSMQ website, so go check them out. And yeah, I hope you guys are having a wonderful day. Thanks for watching, and goodbye.